Good morning. Myself Kiran, working as an assistant professor in the Department of Mechanical Engineering, Global Academy of Technology, Bengaluru. This is the continuation of the lecture 1 where we had discussed about the CAD and the computer graphics software. So, in the previous lecture where we had discussed about the conventional design process. In the case of a conventional design process, we have discussed about the different types of different steps involved in the design process. The first one is said to be the recognition of the need, where we will be able to find out the what exactly is the need for designing that particular product. And in the case of a definition phase, where we try to define this particular problem, where in the case of a definition of the problem, where we are going to define the problem with the help of a specifications, and in the synthesis phase we are going to create the prototype of the component, and in the analysis and optimization phase, wherein the whatever the geometrical element which has been created, it is then subjected to the different types of the analysis. Either it can be the structural analysis, or either it can be the heat transfer analysis, or it can be the computational fluid dynamic analysis. So that means in the case of analysis and optimization, so we'll be able to observe whether the given model created, whether it is able to sustain a particular load or not. That is what is being evaluated in the case of a analysis and the optimization phase. And in the case of evaluation phase, any sort of changes that can be incorporated in the case of a evaluation phase. That means once the model has been created, we just want to change the shape of the component. So that particular change in the shape of the component can be done by reverting back into the synthesis phase. Henceforth, always the analysis and the evaluation stage is always connected to the synthesis phase, so that it can be reverted back to synthesis phase, so that any sort of changes can be incorporated. So once the changes has been done, then finally whatever the geometrical model that has been created which is subjected for the analysis, then it can be presented in the form of a drawings. So just beside that, we are seeing the computer aided design process, where we have four different steps. One is set to be the geometric modeling, other one is set to the engineering analysis, followed by the design review and the evaluation, followed by the automated drafting. We can find that geometric modeling is connected to the synthesis phase, where that deals with the creation of the geometry of the component, and the engineering analysis that is related, that is connected to the analysis and optimization, where we do perform the different types of analysis, that is said to be the structural analysis, or it can be the thermal analysis, or either it can be the electromagnetic fluid analysis, or it can be the computation fluid analysis, followed by the design review and evaluation. That means again that will help us in incorporating any sort of changes to the design of the component. Finally is nothing but automated drafting phase, where we do try to project the different views of the component, as well as will give you the complete list of the parts that is which the component is made out of. So next is said to be the what exactly is the role of the geometric modeling in a CAD system. And in the case of user interface, he tries to represent the component with the help of mathematical representation, where he make use of this geometric modeling technique in order to create the drawing of the component. So in order to represent the geometry of the component, that has to be represented mathematically using these three different phases. One is with the computer display, followed by the drawing generation, and followed by the analysis and the manufacturing. So we'll discuss all these steps in detail in the further slides. Then how do we create the image of the component? So in order to create the graphical image of the object, it can be performed by using three different types of command. So in the base, in the as a fundamental step, in the first step of the commands, that will generate the basic geometrical entities such as the points, lines, and the circles. So by making use of these points, lines, and circles, we are able to create the model of the component. And the second type of the command, that whatever the geometrical entities that has been created, we can do perform different types of transformations on it. That either it can be the scaling, or either it can be the rotation, or it can be the scaling, rotation, or it can be any sort of analysis for the any type of transformation for that matter. And in the third type of commands where it is used to join the various elements so that we can get a desired shape of the object. So how do we represent once we design the component, how it has been represented? It can be represented with the help of wireframe geometry, or it can be surface modeling, or it can be the solid modeling. So here we are finding a sketch of one particular component wherein we try to depict this particular component both by using wireframe as well as surface model as well as a solid model. And in the case of a wireframe geometry, wherein the user will enter the 3D vertices and he tries to join the vertices so that we can create a 3D object called the wireframe. And these wireframe models, so that will lack the surface definition here. But in the case of a surface modeling, wherein the user enters the vertices and the edges in an ordered manner, so that an ordered manner outlining or the bounding one face at a time, so that the surfaces can be defined, and these objects will not have either a mass or the volume. Followed in the last step is to be the last advanced technique is to be the solid modeling, where it is a thing called advanced method of the geometric modeling, wherein these geometrical model created by using solid modeling do possess both mass and the volume. That means in order to subject the element for the any sort of analysis, the geometrical modeling created by solid modeling will be better, because that will possess both mass and the volume, so that it is easier to perform any sort of analysis for this for the model created by using a solid modeling rather than the wireframe geometry and the surface model. So then what do we mean by this engineering analysis? So whenever we talk about this engineering analysis, it is nothing but the fundamental understanding of the natural phenomena, which this consists of the laws of the physics as well as a mathematical ability, so that the designer can arm himself so that in order to perform any particular analysis for any particular object. And these analysis will involve the stress strain relationships. If in case if the element is subjected to the structural analysis, we do calculate the stress and strain relations, stress and strain distribution. Then if it is set to thermal analysis, when we do perform the heat transfer calculations. Then if it is set to be the CFD, that is which is nothing but the computational fluid dynamics, wherein we do perform the fluid flow analysis. And if it is set to be the electromagnetic analysis, wherein we do perform the we try to find out what exactly magnetic flux induced in the material here. This is what regarding the engineering analysis. Next is said to be the what are the different types of analysis performed on the material. So mainly there are two different types of analysis. One is said to be the analysis of mass properties. Then next one is said to be the finite element analysis. So what are the different properties that can be analyzed by using in the case of analysis of mass properties, wherein we do try to evaluate the properties like the surface area, followed by the weight and the volume, the center of the gravity, moment of inertia. For example, for the planar surfaces, we can determine the perimeter, the area, and the inertial properties. Then in the case of finite element analysis, the large model, it is divided into n number, wherein we do try to discretize the large element to n number of smaller finite elements, and it is analyzed for the different properties, so that we can assess the behavior of the entire object when it is subjected to the different boundary conditions. So here we are finding the one particular analysis where we are trying to do that means this is an example of a cooling fan blade vibration, which is predicted by a structural mechanism, wherein this cooling fan blade do produces large amount of vibrations, which can be predicted by using the structural mechanics, by using the mode shape analysis, wherein it does produce a different set of the modes through which we can find out how we can reduce the vibrations in this particular structure. So and these colors do depict the amount of the stress and the strain concentrations along the different regions. In coming to this design review and evaluation part, and in the case of design review and evaluation technique, that will include the accuracy of the design, can be accomplished very easily by using the systems, and it also involves the semi-automatic dimensioning and the tolerance, which will help to reduce the dimensioning errors. So what do we mean by this? And also we can also perform this layering here. So what do we mean by this layering? Layer is nothing but the technique which is used to compare the similar type of images with each other, and it helps to find out the defects. So here this we are finding we are seeing the modeling of the heat transfer in thin layers via a layered material. So here this component is made out of the steel itself. That means we can perform this layering for these materials, so that we can identify any sort of defects that is being induced in the component. And also we do perform the interference checking, and these checking that will help to determine what are the if any parts are intersecting with each other in a assembly model. In case if any parts are not intersecting with each other, so that can be identified easily with the help of this interference checking. And also we can do perform this kinematics, and these kinematics will provide the capability to animate the motions of the simple design mechanisms. That can be Ackermann steering gear mechanism. Any sort of mechanisms can be animated easily with the help of this kinematics. For example, by using this ADAMS software, that is nothing automatic dynamic analysis of mechanical system, will be able to find out the different modes of the vibrations induced along the component here. So this is what we mean by the design, review and evaluation technique. And in this review and evaluation procedure, any sort of changes that has to be incorporated, means any sort of changes in the shape and size of the component can be incorporated easily, can be incorporated easily using this design review and evaluation technique by reverting it back to the synthesis phase. And the last one is said to be the automated drafting. That means once the model has been created, once it is subjected for the analysis, then finally it has to be projected in the form of a model. That means these automated drafting that will help to generate the different orthographic projections, and it will give you the sectional views directly from the solid model. That means in a softwares like Solid Edge, SolidWorks as well as Pro or the CATIA, once we create the geometric modeling, once we create a geometric model of the object, we can extract the different sectional views as well as different types of the orthographic projections directly from the solid mode. And also the dimensioning and the tolerances, including the cross cross hatching, is automatically provided. And it also takes care of different design standards, like whether it is a thick line or thin line, hidden lines, which we do make use of in the case of a solids. Whenever we try to create the geometric model of the component, we try to find out the thick and the thin. We have to differentiate between the thick and the thin lines, which can be identified easily using this automated drafting system. And by using this automated drafting, the productivity can be enhanced rapidly, so that we can increase the production of the manufacturing sector. Thank you.